Hello, in this video we're going to learn about patterns and linear functions and how they relate to tables, equations, and graphs. Let's start with a question. What is the relationship between the number of rectangles and the perimeter of the figure they form? So given this picture here with 1, 2, 3, and 4 rectangles and their length and width labeled as they are, we're going to figure out the perimeter of the figure that the different amount of rectangles form. So if there was one rectangle, like in this first picture here, what is the perimeter? Well, you're going to get 1 plus 1 plus 6 plus 6, which would lead to a perimeter of 14. I'm going to put that in an ordered pair here with rectangles first, so 1, and the perimeter second, which is 14, because we're going to graph this later. So let's say when the number of rectangles is 2, right here, the perimeter is going to be 1 plus 1 plus 1 plus 1 plus 6 plus 6. And so the ordered pair would be 2 rectangles and a perimeter of 12 plus 4, which is 16. Now I'm going to run out of room if I keep putting 1 plus 1 plus 1 plus 1, so I'm going to shorten that a little bit. It looks like there's, for 3 rectangles, we're going to have 3 groups of 2 ones, or 2 groups of 3 ones. So we'll just say 2 times 3 ones, so 6, that's 1, 2, 3, 4, 5, 6, plus 6 plus 6. And so now we have 3 rectangles and 18 perimeter. And for 4 rectangles, looks like it's going to be 2 times 4, because there's 4 and there's 2 groups of 4, plus 6 plus 6. Since this is always seems to be 6 plus 6, let's just write 2 times 6. And the perimeter here would be 20, and that's for 4 rectangles. So now in this box I wrote R, and that's because we're going to come up with an equation here for the perimeter. So notice it always seems to be 2 times the number of rectangles right here. So it's always 2 times R plus 2 times 6, which is always 12. So there's no ordered pair for that. That's just RP because we haven't plugged in an R to get a P. And so we can come up with an equation that is the perimeter is going to equal 2 times the number of rectangles plus 12. And now we can graph that. So I made a graph here. Let me get a dual page. So the graph I made, it doesn't have the negative values on the graph because we're always going to have a positive number of rectangles and a positive perimeter. So I just use quadrant 1 here. I also labeled the x-axis R for rectangles and the y-axis P for perimeter. And so I'm going to graph. So when there's 1 rectangle, the perimeter was 14. When there's 2, the perimeter was 16, 3, 18, and I'm going to go off the graph a little bit here for 20, but you get the idea. So now based on this problem, I'm going to talk about some vocabulary. First, we need to know about dependent and independent variables. So in terms of this problem, the perimeter depends on the amount of rectangles there were in the shape. So we call the perimeter, the P, the dependent variable. And in this case, we'll call R the independent variable. And so when you're solved for like any equation, for instance, y equals 2x plus 5, we would always consider the y the dependent and x the independent. So the inputs are all the values we plug in this case 1, 2, 3, and 4. The inputs are the values we plug in for the independent variable, and the outputs are what happens 14, 16, 18, 20, what the dependent variable becomes. A function is a relationship that pairs each input value with exactly one output value. So this function here, P equals 2R plus 12, this equation is a function, and it pairs one input R value with an output P value, 114, 216. and so on. You'll notice also when we look at the graph here that this is a line, so we would call this a linear function. We would call this equation here a linear function. And that should do it for the video. Thanks for watching.